Hey guys, my name is Ethan, this is Carberra, and welcome to SoulReaper, where I teach you how to analyze and visualize data in Python. Today, this is the last video of the main series at least. I'm going to be showing you how to do k-means clustering. The clustering is particularly useful if you want to just see how data is grouped together. So sometimes if you have a particular X and Y axis, and you'll see kind of these separated groups around, and clustering is just really useful for being able to highlight those particular groups, especially when they're not as obvious perhaps. Of course, if you found the video helpful at any point, then consider liking to let me know, and if you like this series, then consider subscribing to see more on different topics in the future. But yeah, with that out of the way, let's get into it. And we're here in the final episode of at least the main series. Of course, I can still do requests. If you do have any, feel free to leave them in the description. There will be a point where requests close for this series, but you can go to plans.carberra.xyz to find out when that is. But for now, we're just doing a k-means clustering. So what I mean by k-means clustering is essentially we're grouping the data, and we're going to be representing it in different colors to kind of show, certain groups. So if there is like this huge divide, then you can see, okay, well, this particular pattern shows this particular group, or something like that. So we're just going to use from sklearn.cluster import k-means. I have actually done my own k-means algorithm in the past, and it is a nightmare to do. But thankfully, this k-means object makes things very easy indeed. So that's really nice. And we're using the same while partnered dataset that we used last time. So if we actually remember to load that this time. Oh, there we go. That took a while. And then we're going to create our k-means clustering. For anyone that's wondering why it's called k-means, I have no idea. is the simple response to that. It might be worth a look up. But yeah, I'm going to do the same thing as before, where I create the function and then kind of do a little bit of the data here. So again, this is just a 2-column thing. So in this particular case, we're going to do data equals, and then we're going to use the views and then the estimated ad revenue. Here, we don't need to convert it. Ooh, I hit the wrong button there. We don't need to convert it into an NumPy array, so you don't need dot values. And we do pred and then centroids equals k-means clustering data, and then we want to split our data into 3 clusters. So a centroid is the center of a cluster. It doesn't have to be a data point, but it can be. So it's basically just the center, the exact center of a cluster. And in our actual function, it's literally just 3 lines. This, the k-means, k-means equals k-means, and then just pass the number of clusters. There is a lot that you can give it. Apparently the default is 8. That's kind of strange. The initialization function is k-means ++. That's just a bit more efficient than the standard one. There's also, I think there's one involving Gaussian. I forget the name of it. I don't know if it's a type of k-means. It's been a little while since I've done all that, but the k-means one is just, it works fine. And this video, it's not really necessarily to go huge into the theory. Like if you want to know more about the theory, then you can look it up. It's more just kind of showing you how to do it in code, really, with some basic theory here and there where obviously it's important. So I will explain what is actually going on in the function in a little bit. But for now, we can just do our predict. So it's predict again, if I can spell. And then we're going to do data. And then we're going to get k-means.cluster centers. Now this underscore here kind of indicates that we're not really supposed to use this, but whatever. They didn't put it at the start, so it's fine. So now we can get around to actually, showing this on a graph. I've just got it in the paste buffer here. Because it's the same code as we've done for all this time. We don't want to type it out all over again. So we create our figure here. We create a scatter plot using our data views and estimated ad revenue, and then we have SNS scatter plots, and then we put in the first centroid and then the second centroid. We set the size to be 100, and then the color to be a dark color, so it's easier to see. This is actually Carberra Grey. Now it used to be 28, 28, 28. Now it's 0C, 0C, 0C because it makes things pop a little bit more. But we've done C equals pred here. You don't actually have to pass a particular color to it. So this pred is our predictions, but it is. I can probably print it out. It might make more sense if I do that and then just comment all this out for now. Yeah, so it shows us what cluster each data point actually is. So it's ordered by the data points, but you can see that this one is in cluster 1, this one is in cluster 1 as well, this one's in cluster 0, this one's in cluster 2. So the color is dependent on the number here. So it goes through each data and then it checks back against pred, and then it sees, oh, this is 0, I want to turn it into blue, or this is 1, I want to make it orange, and it does all that stuff for you. But if I actually show you the graph, I mean, the colors it picks by default aren't the best. You can probably look into that yourself. You can see that all this data here is in the first cluster, all this data here is in the second cluster, and all this data here is in the third cluster. So there's not much in the third cluster. And then you can see these black dots here that represent the centroids. These are just the center of the graph. You don't necessarily need these, I don't think, in like production environments or whatever. But they're just there to kind of show off. So what is actually happening here? Well, I'm actually going to bring up my own k-means method that I actually developed myself without much help. I googled around a bit, but I thought of this myself. It's not perfect, but I'm still quite proud of it, and it will show you actually what's going on in the background. So I'm not going to include this in the actual in the notebook. I included the extra polynomial regression function last time in the notebook because it was like 3 lines or something. This one is long. There's a lot to, I mean, a lot of this stuff we don't need to care about, but there is a lot of stuff to talk about here. So firstly, I just want to point out these 2 functions. This calculates the Euclidean distance between 2 vectors, and this one randomly selects k points to use as centroids. So k is the number of centroids, or the number of clusters that we want to create. In this case, it randomly selects points from the dataset. However, you can just randomly select a point in the graph. It doesn't have to be a point in the dataset. Or you can actually calculate it beforehand to try and get a more reliable view. Because sometimes if it chooses 3 really close together, the actual clusters can be wrong. I believe this one actually does that because this uses ++, and I think that's the difference between this and k-means ++. But I could be slightly wrong about that. So we're going to ignore these for now. We'll come back to these. But firstly, it gets the initial centroids, and then it just creates an empty array for the aggregate distances. And then it goes into this while loop, and it appends the numpy array with 0. You're not really supposed to append stuff to a numpy array, but I did it anyway. And then it gets the initial clusters. So in this initial clusters, it's just, I'm pretty sure it just kind of creates just a set of clusters to use. But I don't think it goes through here much. I don't really remember what this is doing. Oh no, it creates an empty array, and then for iron range k, so it gets a number of clusters, and then okay, so it actually, right. So what this is doing is it's creating a number of, I think it's creating a 2D numpy array, and it's putting the centroid into the relevant cluster. I believe it's what it's doing there. So it's been a long time since I looked at this code, so I'm just kind of working it out as we go. And it goes through the data set, and it looks at every sample, and it gets the closest centroid and the distance using this function to get closest centroid. So essentially it just starts with a super high value, and it has this closest placeholder that it uses, and then it essentially just goes through using this Euclidean distance to work out which one the closest is. And at the end, it implants it into the correct thing, and then it returns the closest centroid. I'm not sure if it's returned the centroid or the cluster. Oh, it's returned the centroid itself, and it returns the actual distance from it. Then we have this index here. I believe, I don't quite remember what that's doing. Oh no, that's actually getting the cluster that the centroid is in. I see. And then it appends the cluster it appends the sample to that cluster, and then it's okay. So it adds the distance to the aggregate distances that it uses there, and then it adjusts the centroids after that. So, it adjusts the centroids. So this essentially puts the centroids in a new position based on the clusters that were created before. So it creates these centroids here, and it does this. I remember this line took such a long time to work out. I think I spent literally like a day just trying to work. I think there was some sort of issue with this line. I don't even remember what it does, unfortunately. And then it checks if the current centroids are equal to the new centroids. So it's essentially, it kind of like slowly shifts them to create more equal clusters, and it kind of shifts them into the center of the data points that it comes out with. And if it finds them to be correct, then it breaks out of the while loop, and then it returns this. The new centroids, I think this was the issue. I had to return the transposition of the new centroids, otherwise it was just being weird. I still don't know why that is. Returns the cluster in the aggregate distance. It does all this plotting down in the background. But essentially, in short, what it does is it gets the initial centroids to use. It then forms some clusters. It goes through every single sample in the data set and works out which centroid it's closest to, appends it to that cluster, and then using those clusters, the centroids are adjusted. If they don't move, it's determined that the centroids are in the right place and the clusters are fixed, we'll call it, I suppose. And then it returns, the centroids and the clusters, and then it does all this other stuff. Well, in this case, it returns the aggregate distances. I don't remember if I even used that. Apparently, I do somewhere. There we go. I use it here. I don't quite remember why. Plot and stylize objective function values. Oh, this is objective function. Oh, God. Don't even get me started on objective functions. That was awful. But yeah, hopefully that's kind of the base theory. If you want to know more about k-means, you're gonna have to look it up. But this isn't so much. I don't know. Maybe I will do some more intensive theory stuff, where I actually do proper explanations on these things. But yeah, for now, this is the code to do it. That's a base explanation of what's roughly happening there. And that brings us to the end of the main series. As I said before, you can put requests in the comments, or you can go to the Discord server and put it in the video requests. If you have any questions, you could do the same thing. So, leave it in the comments, or ask in the support channels in the Discord server, specifically not the video request channel. But yeah, with that, I'd like to thank my incredible patrons for being amazing, and I will see you next time where we do something else, probably Discord.py music requests, I imagine, because I'll try and get this recorded and ready to go in time, so there isn't really a gap between stuff, because that's what people wanted to see next. So I will see you for that.